Alright, Chapter 3, Project Structures and Layout Toolset. This is the complete PCB design Orcad capture layout. This chapter explains what you did when making simple design. Chapter 2, why it also introduces describes layout toolset greater details so you will be able to equip the layout more completed complicated boards in Chapter 9. Project setup and schematic entry details capture projects explained. When you set up project file, new project menu path, we have 5 options to select from: a project design, a library, a VDHL file, or a text file. The option we may be interested in project or libraries. We look into the greater detail throughout this book. The VDHL files are either the field programmable gate array projects will not be discussed here. A text file is simply a text file for making project notes. For example, after you select the new project option to begin setting up your project, there were 4 more options available to you in the new project dialog box: analog mixed signal or AD, PC board wizard, programmable logic wizard, schematic A. The following diagram and options and sub-options: Figure 3.1, Figure 2.2 shows analog mixed signal. AD is used to simulate analog and digital circuits using PSpice. PSpice was used to develop the test models in Chapter 7, performing circuit simulations in Chapter 7 and 9, simulate transmission lines Chapter 11. For now, we'll be working mostly with the second option, PC Board Wizard. Will focus on the design of PCBs. Next option, the Programmable Logic Wizard is formed with the programmable devices will not be discussed in this text. A schematic is basically just a design file with only schematic and parts cache. That green line in Figure 3.1 shows the path you followed in Chapter 2. Filed new project PCB board, no simulation. There are 4 types of Orcad libraries, as shown in Figure 3.2. The 4 libraries have 3 different file extensions. There are 2 types of OL libraries, an LL library and LIB library. Inside of the capture folder, there is a library folder which contains one of the types of the OLB files, and a folder called PSpice, which contains other types of OLB files. OLB files are library files located directly in the capture library folder. Contain simple schematic part symbols are ones that we use in Chapter 2. Libraries located in the PSpice folders contain parts with schematic symbol too, but parts also contain PSpice templates, which links for them to specific PSpice models. Many of the parts have layout footprints assigned to them. Alright, so we now went to new mix single. We've created it based on an existing symbol, a hierarchy, creating a new project setup finish, default capture library, splice OLB, PCB board, enable simulation, yes. And then we go no, add PCB part symbols, capture library OLB file, setup finished. Alright, the PSpice model with the templates of the point are located with the main Orcad PSpice folder. As shown in bottom Figure 3.2. Individual models are grouped into various PSpice libraries, as shown for the library extension. Layout library folders contain a footprint library file with the LLB extension. So the layout file library has the LLB extension. Most part of the captures are capable of having a PSpice template or footprint assigned to them, but only some parts have the pre-assigned. It may be seen backward. Only parts of the PSpice part library located in the capture library folder have pre-assigned templates and footprints. So in Chapter 2, when we worked with the PCB project wizard, we selected the libraries from capture library folder that had parts of the schematic symbols that do not have any PSpice simulation capabilities or footprints assigned to them. So this is your Orcad CAD library or demo tools. We've now looked into the library, schematic library, OLB, no simulation capability, PSpice, schematic library with simulation capabilities, your layout library, LLB, and your PSpice model library with PSpice templates. Once you finish the PCB Project Wizard box caption, open with the Project Manager shown in Figure 3.3. Behind the scenes capture generated with the 2 files as Project Manager Or Orcad project file name, whatever you name your project, the design name, and design file will be in DSN. These files will be in the directory choose your setup project. As you look in the project manager window, you can see that the setup project contains 3 folders: design, resource, output, reference projects. Initially, the output and the reference project folders will be empty. We will look at the folders greater in detail in chapter 9. The design resource folders contains one design represented with the icon and library folder. A project can have only one design, but designs can have several subfolders, which in turn may contain several different items. Library folder contains links to the libraries used by your design. We'll discuss library management in Chapter 7. The design contains at least one schematic folder, the root folder, and the design cache folder. A design can contain multiple schematic folders. Each schematic folder can contain multiple schematic pages. The design cache folder contains a record of each part you have used in your design. If you modify one part of the schematic page, Capture makes a copy of it, leaving the original part of the library unchanged, adds a record modified to the part design cache. Design with one schematic folder, one or more schematic pages are connected together by off-page connectors is called a flat design. A design with more than one schematic folder and one or more schematic pages per folder that contains hierarchical blocks is called a hierarchical design. Hierarchical designs are not discussed about here since they are not using PCB design projects. For more information, project details, Chapter 2 of the Capture User Guide, starting new project, Capture underscore user guide, PDF, Orcad 10.5 demo doc folder. Capture part libraries explain whenever the project was set up. The next step of the open of the schematic page. If it was not already open, begin placing the post drop down menu when the page part with the dialog boxes 3.4a and 3.4b show the list of the libraries. And libraries window, list of the part list window within a library is part of the one of the libraries. You can see what the parts of the looks like. And preview windows is pointed out in Figure 3.4a. The libraries are listed in libraries. Which one? Windows are ones that were added to the PC board wizard, which when you set up the current project in libraries that were added to the listing during previous projects, you can add other libraries by listing and clicking the Add Library button. Likewise, you can remove the library from listings by selecting Click or Remove the Library button. Libraries that are listed may be from the Capture PSB Splice library. It's not obvious which library it is, or just by looking at the name. Compare Figure 3.4, 3A, and B. However, if you have the Windows Tooltips turned on, hold your mouse button over the library name. The Tooltips text box will show you the path of the library. Figure 3.4a. From the path, you can tell which type of library it is. Another important note with the PSpice of the layout library is associated with the Capture part, where you'll see with one or both icons below the past preview window. It's shown in Figure 3.4b. If no part icons are present, then it's maybe just the Capture schematic part, or that does not have any footprints of the PSpice templates models and assigned to it. Alright, so Figure A shows place part with the captured parts in A. Preview window, tooltip, PSpice icon, layout icon, parts, capture parts, and PSpice parts. As you place your parts on the design, keep track of the parts and store the information in the database file generated in that moment that you place your first part. That file is a DBK file extension finished for the design told to Capture to make the layout of the net list. Capture generated fourth line with the net list itself, describe which part of the user and how they were connected, and format layout uses. Layout net list files or MNL or file extensions added with the directory of the other project files unless specified otherwise. Later in the design process, you can note the PCB information into the Capture design through the use of SWP file layout creates. PCB information imported into the Capture added to the net list and net listings file, so that when you update the PC design later with new information from the capturing using auto echo, changes made from the PC design into the layout are not unintentionally undone by Capture if they still synchronize. More will be discussed backnote annotation in Chapter 9. Understanding layout, environment, and tool set of the board technology files. At this point, Chapter 2 of the chart layout will assume that the next logical step would open the MNL or netlist file, but layout needed to know the type of the board technology to use first. This is why you need to select new from file menu, select the TCH or template for technology template for opening the net listing file, which is the default TCH template to start with, but there are 21 different types of in the version 10.5 demo from which you could have chosen. They are all board templates which have the TPL file extension that has been set up with the custom boards technology files. Set with the numbered allowed layers, pad side of the drill side of the ICP pin pad of the dimension U of the metric mills, the default technology files assigned level A with multi-layer board, 3 design levels specified by the Institute printed circuit board is covered in the detailed chapter 4. There are levels A, B, and C. The design levels in Orcad layout with the relay with the IPC design level to do not necessarily map directly into them. Both layout with the IPC level A is general design complexity standard IPC 2221A contains tables related to those who are known as standard fabrication allowances. Layouts using standard fabrication allowances are to be set baseline routing and spacing rules. For example, level A technology and layout allows only one trace between DIP and IC pins using 62 millimeter or 62 hundredths of an inch and 38 mil drill holes of the ICP, and then 25 mil routing Viva grid, 100 mil component placement grid, 12 mil routing space. Technology file with level B and C. Design complexities allow 2 or 3 traces between pins respectively, so IC pins are smaller to make room for additional traces, and some or few of the technology files is shown figure G in table 3.1. Technology templates are discussed layout in the layout user's guide LA underscore UG PDF in chapter 4 under technology templates in appendix A. After selecting the technology file layout, ask for the netlist file with the MNL, the file that you generated and capture layouts, adds additional information, puts it into special. Alright, your default is a design complexity A, your 1 beta NA, same difference, 1 trace of the ICP pins. The second beta SMT, similar to default, geared towards source mount boards, routing parameters, and more compact, that's a B. And so was the second thorough hole boards, 2 trace between IC pins. And you have a third beta, which is any high density mixed package board, 3 traces between IC pins. And then Tutor uses the layout tutorial, and that's also as an A degree. Issued formats, saving in max. The max file contains information such as board size, components both physically located and size, location of the traces, along with the information capture put in the original net listing file. The auto eco utility, after saving the best design information in the new max file layout, the automatic engineering changing order. Ultimately, all utility works to link footprints from layout library to packages footprints listed in the original in the net listing. It also generates the other files such as the name, log, name error, and name listing. No, from the time you start with the design capture to the time you process the board layout, you can also nearly 40 files with the generated, which should give it a fully describe your design. If you save more than one project in the same folder, they become very cluttered. It's a good idea to set up with a My Projects folder that contains subfolders for each project. If no footprints were assigned to parts in capture, if one was assigned that does not exist with the layout footprint library with the auto engineering changing order, brings the link footprint to component dialog box. Figure 3.5 gives 3 options: linking a footprint 1 of the layout libraries, 2 making a new footprint now and linking it to the part, or 3 do not do anything right now. Alright, and link of the footprint component shows the automatic engineering changing order cannot find footprint X in the component C1. Choose any one options below, and then we've been given these options. Chapter 2, we selected the first option, locating the existing EX guideline layout library to find the SIMTML L202 footprint. Once you've selected the footprint, engineering changing order automatically link to the footprint to all the components the same type that were in the net list. Every capacitor 1, 2, and 3 from the discrete library have been that you place in the schematic. The auto engineering changing order utility brings the linking dialog box every type of the component from which we could not find on the footprint. Layout keeps a record of the information. Automatically use the footprint default footprint for the component type of all the future projects. It can also make sure you assign the footprint in the capture before you generate the net list. If you forget to assign the footprint ahead of time, layout assigns the default footprint. You can also change the layout and capture it afterward. If you choose the second option, create modified footprint layout library editor will automatically open footprint that can alter the existing footprint, make the new footprint or you can save the new footprint. You can close the footprint editor. You can taken back to the auto engineering changing order utility with the same three options you started. However, now you can click on linking existing footprint to component and linking the footprint you just made with the auto changing order utility is asking about. If you choose the third option, defer remaining edits until completion. The automatic engineering change order utility continue with the rest of the net listing. Looking for the parts of valid footprints and the footprints have not been assigned by the time of the auto changing order utility has finished for the auto engineering changing order will fail. The board will not be generated. We'll start with the process over again. Once the auto engineering changing order utility finishes with the link, the footprints for the part of the schematic layout will open with a design window for the part of the automatically placed on the left of the origin. Connect with the yellow line with the rat nest. From this point of the line you made with the board with the outline played with the parts of the board. Routed the board or processed it to be fluent with the task. If you need not to know how the layout tools, you will know. And I'll take a tour of the layout environment and tool set. Session frames in the design window. First, we'll back up with a step of the second look at the layout session frame. Design window will start layout before initial importing the net listing. But the first thing you see with the session frame is shown in Figure 3.6a. If import with your net listing frame, auto engineering changing order utility finish creating with the max file layout depending on the design window for the project is shown in Figure 3.6e. It's possible to close the session frame and leave only the design window open, but leave the session frame open the design window because the session frame acts as a director and helps you design an interface with the other applications such as Capture. Also possible to have more than one design window open, but is best. Figure 3.6a layout project A, project environment, the session frame, and then the design window. To have only one open at a time because it inadvertently makes the undesirable change with the one that is working with the others, and especially true with the performing with the design update with the capture layout with using auto engineering changing order tool for more than Chapter 9. The session frame starting point with the working layout for the session frame file with the menu bar with the start with the new design with opening existing importing a design file from another application, pads, ProTel, etc. From the session frame tool pull down menu you can access the layout initialization, LS session initiation or layout initialization and initializing file. Change your application setting. You can change the library menu with the footprint library. You can also create the print a footprint catalog with a particular library as designed in Chapter 7 for any example. The tools menu also provide with the connection with the other applications such as Orcad capture for the Gerber tool depending on the option that came with your package. From the tools menu with the select with the type of the forward annotation design update with the captured layout you want to perform the use auto engineering changing order tool. There are several types of the engineering changing order. 6 types are either the transfer tab with the capture layout during the forward annotation. 7th is auto exchange engineering changing order net attire attributes transfer the information being printed circuit boards. The 7th is the engineering changing order are discussed in detail in getting started Chapter 2 in the layout user guide and the discussing auto engineering changing order sections at the end of Chapter 9 of this book. Design window is working with a working environment for the board design. With the design window has access to the tools needed for the panel, for the parts, route, for the tray, for the perform, back annotation, design, update of the layout to capture. There are 200 tasks that can be executed with the design window menu since they are covered in chapter 20 of layout user guide. See the layout command section, detailed discussion of menus. We will not be given here. A few key menu options we'll discuss in chapter 9 as they need to arrive at the toolbar discussed below. Toolbar shown in Figure 3.7. Although the user guide does not describe the tools on the toolbar following way, you can think of the toolbar as divided into functional sections: general project tools 11 tools, other object selection tools 6, manual routing tools 4, environmental control tools 5. These tools are described below. From the left, generic project tools, object selection tools, environmental control tools, manual routing tools, and then it has the design result check. And that's 7 toolbars. 3.7 toolbars. Adding additional information with the toolbar can be found with the layout, design, environmental user interface with the toolbar, table 3.1, chapter 3 of the layout user guide. General project tool button. The general project tool buttons are related action pertaining to the project as a whole. The general action can be applied with a multiple object with components of the or text within your object. Most of the tools exhibit the common Windows functions, but they are coupled to function the unique and layout. The general projects are the tools as follows: open file, similar with the Windows open file tool with the gear tool of the files used within layout. It can also use the Max project default, the template file, or is a TPL or TCH technology file, strategy SF file, or footprint library. Same action can also be performed with the file open drop down menu bar. Save project tools, saves to the current Max file with no suppresses here. Same action can also be performed with the file save the drop-down menu bar. From the file drop-down menu bar, you can select and save the current Mac project as a Max file with a different name. You can also serve the project property for having the same project as a template, TPL, TCH, or strategy file, library file, post-processing setting file, or a color setup file, and an arbitrary list file. The additional details example generating templates are covered in Chapter 9 of this book. Library Manager. You can edit, construct with the footprints and pad stocks. You can invoke with the Library Manager with this button. You can select the My Library Manager from the Tools menu within the main layout session frame. Sign footprints, pad stocks is covered in detail Chapter 8. Delete toolbars is grayed out on inactive. If nothing selected, it becomes active. There's something that has been selected with the mouse. That if you delete button selected object deleted, you can also have the same thing, delete key, with on the keyboard action with the deleting selected object that causes a significant change with the problem with the project layout. Stop and ask if that is in fact what you want to do. Find. When you click the Find tool, the Find Coordinator reference designator of the dialog box pops up. You can enter for the part with the specific pin or part with the specific location. Find tool will move the cursor spot the center of the view of the tool of there. There are other types of the search tools which are described in detail in Chapter 9. Alright, finding coordinate and reference designator. It gives you U111 item number for the Find dialog box. Alright, edit. If you have the object component or net, etc., select the checking the edit tool brings up the edit property dialog box and perform the same function, selecting object, right-clicking on it, and selecting property from a pop-up. Spreadsheets are used extensively layout, interacting with and manipulating many times with the parameter reasons. Spreadsheets used to provide convenient way with the organizing, despairing, playing large amounts of the properties at one time. There are various users interface with the provide convenient means of the modifying of the properties and shown with the various spreadsheets are accessible to the drop-down list that appears when you click the spreadsheet button. Spreadsheet button will be used and discussed often throughout this book. You can read more about it in Chapter 3, Layout, User's Guide, and Layout Design Environmental Spreadsheet section. Alright, you have your zoom in, zoom out, and center zoom. Press the zoom in, zoom out button. Those were, again, I think it was O and I. And change the crosshairs to zoom cursor with the zoom in button. With a click on the spot with the workspace. Click with the point with the center view with the view with the automatically zoom in. Same thing As true for the zoom out button, drag button, the area of the zoom will encompass the box impossible regardless of the zoom in, zoom out buttons were pressed. Zoom all center boards and zooms in and out and even to fit the entire board with the screen. Enables you to see the entire board as large as possible. You can also zoom in and pressing the I key of the keyboard, zoom only. Zoom out pressing the O key of the keyboard. You can also pan the board with the keyboard, placing the pointer where you want the center view and to be able to pressing the C key. Alright, your options, spreadsheet menu, spreadsheet tool button, which is on the little spreadsheet thing. Again, strategies, tool, layer, blah. Query window combination object selection tool with the object with the property. For the example, the query window is shown figure 310. Query window is quite powerful. It does more than the display tab. For the query window is interactive. You can click on the keywords line with the text of the window bring up pop-up menus that are exact unique to queries. For example, if you have a simple board project with chapter 2, with the click of the query button with the open the query window, inside of the window, right click with the Q cursor, select the find to go to the pop-up menu. Type C with the click O font K font capacitors, and query window will also list the capacitor within the design. Next right click and again select the properties from the pop-up menu. Click C2 for the component C2 with the test string, and the query window will also show the information to C2 such location package as figure 310. Selection tool component. The component selection tool button is quite powerful. It provides numerous options when working with the footprints on the board. Figure 311 shows that have the component tool button activity. Right click on the background with having the component selected. You get the pop-up menu 311A. The different right clicking when you have a Figure 310 shows the query window. 3A is without component selected. 3B is component selected. Component selected in 311 and B. Basic purpose of the component selection tool will select the modify, the move, modify, delete the component footprint. It possesses all their capabilities except for how many functions are given in Chapter 9 of the design examples. If you want to read more about the component tool function, please see the layout user guide, Chapter 9, placing editing components, placing component manually selection, and then shove the pin. Basic purpose of the pin selection tool is to select and move the modified delete a pin with the footprint, and for the component selection tool will right click with the different pop-up menus depending on whether you have a pin selected or not. When you have some of the advanced function of the pin tool, Chapter 9, one example of the pin tool is modify a tool footprint pin on a board without opening a library change. This is allowed only when they're checking allowing editing of the footprint box. If the user preferences dialogs will exit the user preferences for the option menu. If the auto editing of the footprint box is left unchecked, it will not be able to edit any of the board's footprints or the pins within the footprint. Obstacles. Alright, obstacle selection tools allow you to select, then edit, move the copy, delete obstacle with the graphic object, the define appearances and parts, and restrict where the components and tray that can be placed on the board. Common obstacle, the silk string part, outlines, board outlines, copper pore areas, insertion outlines, placing outlines. This is the trick to moving the obstacles. Move an obstacle without stretching, with distorting it. Press the control by left click on the obstacle with the left click and hold the obstacle with the drag it to the new position. If you click on an object but its edge of the stretch of the obstacle segment and sometimes adjacent segment, use the left click and the control to resize the object. Copying the head of the obstacle, control left click on it and right click on select with the desired action pop-up menu. If you want to paste more than one copy of the obstacle for an object of that matter, position with the cursor of the desired location, press insert key on your keyboard. Hold the version layout with the right click and then select paste, and if you will be able to paste on only one copy of the object to paste additional copies, you would have the copy of the object repeated. Newer version layout, you can use the paste command repeatedly as you would in other Windows applications. You can select more than one obstacle at a time, holding down control key, then left clicking on each obstacle you want to select. Text. The text selection tool is straightforward. You can use the select with the move, the edit, copy, the delete text, and the obstacle. You can use the insert the key on the keyboard. Use Control plus V for the repeatedly paste copies of the text object. Connection tool is use to create the nets of the PCB or not in the after schematic net list. Use the split nets and delete pins connected to the nets. Disconnect pins. From that's an example of which could be used with adding guard traces for the PCB, as described in Design Chapter 9. Change of the nets and pins may be used and connection tool cannot be made and noted to the schematic diagram. Error marker selection tool allows you to select an error mark to find out what the error is and location. Error marks are generated with a direct running desired result. Direct running desired result. Your DRC. Desired result check below. Have you identified the design rule check below? Helping you to identify the design rule violation. You can also enter the mark tool with the query window to display the more information about the error. Environmental control tools, color setting with the control button with the straightforward with you with the control of the color of any layer, object, obstacle, the pin name, with etc. in your design. Also, one of the tools you have the layers visible and invisible examples with using color setting, but with the training with the color nest, the thermal reliefs are given in Chapter 9. Alright, online design rule check. The online design rule check encompasses the area with the defined with a rectangular box, rectangular area with the color of the route box with the design rule check box. So the online design rule check box is inactive. It is not visible when it is active. The rectangle with the made with either dotted lines or solid lines. Appearance of the function of the box depending on what you're doing on the board at the time. When a route box is dotted with the standby mode, when the actions are being performed to simulate the only design rule check to monitor was going and the boundaries becoming the solid lines. One of the function of the design rule check is to prevent you from performing certain actions, route tracing, or placing components that will violate spacing rules. Another function is to focus on auto router particular areas board during various stages cause sweeps and passes for the auto routing. You can usually toggle with the online design rule check on and off anytime except with the performing certain manual functions of the auto path route with the mode and show the track mode is discussed below. Reconnect mode, the tool show and hide of the rat's nest. It does not really distinguish the reconnect things. It just makes it to look like it. Simplifies view, placing parts on the board. It can be used in conjunction with the component tool. Select any with a command and edit drop down menu. Refresh. Pressing the refresh button not only repaints the trace for the copper area of the current view on the display with the redraw of the unrouted connection of the rat nest to minimize their length. So update for the thermal relief connection of the plane layer. The refresh also called the board statistics to be recalculated. Statistic spreadsheet, for example, statistic calculations when in double hit the refresh button. Alright, project design rule check. When you press the project design rule check tool button, layout checks the entire design rule violations that are set when the change design rules dialog box figure 312. The action for the check design rule box. Go to the auto menu design rule check. Auto errors found with the running of a design rule check are marked with the error mark circled X and can be investigated using error mark selection tool and query window and discussed above. So you have the check design rule, check the rules, placement, setting, violations, net rule, copper, continuous Viva location grids, exit violation, SMD fan out, test point, violation, check copper, select all, check detail, optics, report, direct, design rule, check, route box violations only. Manual board, route, and edit mode tools. The four manual routing tools can be used with completely manual mode, with or without the online design rule checkbox. The other two manual routing tools are actually semi-manual because they only use the online design rule check function, interact with the auto router. Manual routing tools. The manual routing tools edit segment mode, edit mode are used when we have to complete control over the traces that are routed. These tools can be used within or without online design rule check tool. Add and edit route. Add and edit route is the two route with a new track for the rat. Then the edit with the tracing with the only segmented with the time. Automatic finish for the partially routed trace. Automatic finish straight for the edit of the mode with the build route trace of the current location through the short path of the possible. If you could do so with the violation design rules, it may be temporarily into the edit segment and map mode. Do so. Add edit route mode. You can also add V with the typing of the number of the new layer which you want to continue routing. Add edit route mode does not automatically use auto route algorithms, but it can activate only the online design rule check. If you want, if the online design rule check is not active, you can route trace whatever you want, even if it violates design rules. The only design if the online design rule check is active, the outer router functions will automatically add vivas and shove traces to prevent major design rule violations. Alright, edit segment mode. Primary purpose of edit segment mode is move the routed segment vertexes easily. You can use the edit segment mode unrouted nets that behave similar with the edit mode. If you select the center of the routed segment, with the move the vertical segments to the left and the right, move the horizontal segments up and down. If you select the routed segment endpoint of them, you can move its vertex. You may move the segments like create the angles based on the manual route setting. Maintains Lego route patterns. Edit segment mode can also be used to combine and remove segments, route unrouted nets, and move the viva tied to the nets that are not locked. Interactive manual routing tools. The interactive semi-annual routing tools, AutoPath route mode and shove track mode show the automatic routing algorithms traced on the nets that you select. When you select one of these routing tools, the online design rule check is automatically activated. AutoPath route mode. When you select the completely unrouted net, and AutoPath route mode calculates the best path that suggests the entire trace should be look like, and suggests the traces within a trace of the same color with the active layer. Then it will click on the OK with the out routes for the trace with the boundaries on the route box. This for the trace the already routed, and you click on you suggest the new routing path depending on whether you move your mouse. As you click on the various places with the temporary add vertex vivas, suggest the new route pass until below you, and you click the same spot with twice and right click with the select the finish view with the pop-up menu with the layout with the reassess the proposed routing path. Automatically adjust for the best fit. Use the routing strategy settings and pushing shove the capabilities for the auto runner, and so since it performs the final best fit, the final track may end up looking completely different from what it's originally suggested. If the click ends with the command of the pop-up before the complete rerouting trace at the top of the auto router to leave any unrouted part of the trace as the rat's nest line. Alright, shove track mode. Shove track mode is similar with the add and edit route mode, except for the auto router is active. The auto router assumes if the tracer currently routing the highest priority, automatically shove the existing tracing out of the way. This allows you to force the trace you are working will only be routed and place existing traces at the same time, ensure you that none of the traces violate design rules. If no trace to shove out of the way, shove the track mode behaves like an add and edit route mode. Other indicators and controls, the posted stamp view. The posted stamp view is located in the upper right-hand corner of the design window to give the bird eye overview large boards. Red square represents your monitor, and the yellow outline represents the PCB outline. When the posted stamp view is interactive, is interactive. If you double click inside it, it will perform a zoom all function. If you click on one side of it, it will serve the main view at the point. You can also draw a box inside of the posted stamp to zoom into that area of the board. Cursors and coordinators placed in grid indicators. Below the toolbar, course and coordinators placed with the grid resolution display. Figure 313A with the active layer with the control the drop down list. 313B with the course coordinate with the default with the mills of the board, most board with the relation with the board general origin. Place grid setting determines how the fine control for the placing your parts. Smaller grid number with the finer control. You should use the default value of the board technology on your board when possible. If you use the smaller grid with the same with the increased risk of the introducing design and manufacturing errors, but there are times you will need to set a smaller grid working with the footprints with the pins that are not in standard pits. See Chapter 5 and 9 for guidelines or grid settings. Figure 313 cursor location grid locate indicator layer tools. A coordinate cursor coordinates placement in the grid, and B active layer drop down list. Layer control list allows you to select the layer as inactive as you work on it, and allows you to disable to make it invisible with the enabled list. In addition, you use the layers control list. Each layer has a hotkey. You can use actuate with the number of the keys. Use the keyboard list the full hotkeys. Click on the spreadsheet tool button. Select layers, and you can use the hotkey for the layer control list of the selecting layer. Then use the negative sign, keep it on the toggle on and off. Another way with the control layers is pressing the color setting buttons on the toolbar, bringing up the color spreadsheet. Left on clicking on the layer cell with a spreadsheet to select it, right clicking on it, bringing up the edit layer list. From there you can turn off the layer and on and off to changing its color or even deleting it. Now that you know the tools for moving parts, working on the obstacles in the text, the next task is to learn about the auto router. In controlling the auto router, there are three general types of CAD auto routers: grid-based, shape-based, and topological. Orcad layout with a grid-based router, although smart route with an optional add layout with the shape of the base router. Simply put, with a grid basing routing character supports space in terms of the grid coordinates starting with the endpoints of the pins for each net location of the obstacle. The grid based router with attempts to the route traces of the grid, avoiding obstacles, obeying specific design rules after route of the tracing. Auto router checks to see if the trace it is just routed violates any rules. If any rules are violated, it will show the trace of the nearby grid location recheck with a new violation. If it cannot simply show the trace without causing violation, it may rip up the trace and try a completely different path. The outer router will try several iterations of the routing, checking, rerouting until either of the traces is legally routed or it gives up. These iterations are being called sweeps, and passes are discussed in more detail below. Design number 9 needs for the high current power supply board significantly different from the needs for the low power high frequency or RF or digital board. The wide spacing trace of the number of the VIVA can either significantly affect the power handling ability crosstalk of the board. The two files that initially loaded with the copied into your design with the routing rules for auto router. The two files of the board technology template within the strategy file. These files are located in the data folder of the Orcad layout file path. Board technology file will be discussed above in C table 3.1. The set of the baseline board line complexity number, the allowed layers, the pad size, the drill size, the trace width and spacing units, and etc. Strategy file dictates which of the allowed layers are the routing layers. However, when not in use in Viva, the general tracing requirements such as the direction, horizontal, vertical colors, etc. Routing window size. Default strategy file will be automatically loaded with each for the new design, but it can be changed by going in the file below drop-down menu to select from the standard file you want. There are 37 different routing strategy files provided with the Orcad layout 110.5 demo layout plus. There will be a component placement strategy file with a strategy file extension, but they will have the file name of the PL best strategy file extension. Automatic placement will not be discussed here, but you can go to the layout users and guide in chapter 9 for more information. If one of the routing strategy file will provide with the layout does not suit your needs, you can make your own, load it into your design. Preferably, you can simply modify with the current strategy file setting. You can modify the strategy file setting through the use of 3 dialog box to access 3 of the dialog box options or menus to specify option system settings, routing strategies, routing settings. There's some of the overlap between the dialog box and overview of the control provided in table 3.2. You can find more information on routing controls in chapter 4 of the layout user guide and design files. That was chapter. So here's the option system setting units, grid settings, routing strategies manual, Viva the retry, route limited attempts, route layers, routing enabled layer cost, primary direction, routing between pins, route sweep, directional routing control, sweep direction, route box size, route book size, route books, overlap, route passes, pass tests, enable done, pass type options, setting systems, aim of system settings, route settings, route mode, interactive auto route settings, manual route settings. Alright, sweeps and path. The auto runs numerous iterations of the form sweep and path with the auto route breaker breaks the board in smaller area with the define with the route path to make it easier for the auto router algorithm. Sweep contained with the routing object with the file within of the given route box with a several different sweep type with chapter 18 layer. User for the guide with the sweep the edit box. Chapter 20 under route sweep command for detailed various sweep types for the execute for each route with the box for the path routing session with you for the particular routing algorithm while given in the sweep of the 6 different algorithms, but every algorithm These during a pass of the layout user guide in Chapter 10 under the edit route pass of the dialog box. Chapter E with the under route pass command. The type of the number of the routing algorithm is used in each of the paths depending on the particular routing objective defined by sweep. Fortunately, unless you are designing a highly complicated board, the only parameters you will likely need to adjust the grid setting, but you can also adjust the sweep and the route settings if you need to have much control over your design. Alright, automatic versus manual. If these boards specifically special routing requirements, you are intimately familiar with those requirements. You can fine-tune with the auto route with a different strategy of the file of dialog box described above. However, the considerable amount of time spent to be spent on setting up the sweep and passes for a particular board or trace type in order to find the tune of the payoff. There is no need to be quite few traces with similar same routing requirements to digital boards with wide data buses. However, the only one of the two traces special requirements would probably be ahead. You manual pre-routing traces will then look the traces auto route the rest of the board using standard settings. You will see an example in chapter 9 of this book. Clean up during the routing process. Some traces of the Viva that does not violate design rules could be present in the general manufacturer problem. These type of problems include traces bad angles, traces of Viva that are off-grid, bad pad exists, problems, copy error of the cleanup with the function check for these issues. The automatic corrects them. Can also be set up into the miter corners, clean up with the project database for the unused pad stacks, footprints, and cleanup action that can perform as many times as necessary with any type of during the design process. To perform a cleanup, select cleanup design. Auto drop down menu of the dialog box shown with 314 will pop up. Remember the override lock tracks unchecked if you have a trace that you want left alone. Locking traces. Protect a trace from being disturbed during a cleanup of the other automatic actions. You can lock the trace by choosing the manual routing tool. Select for the trace you want. Lock down, hold the control key, and click on the trace. Next, click on the lock. Select lock on the pop-up menu. Also, layout user's guide, chapter 10, manual routing techniques, locking routed tracks. You can unlock a trace using the same basic procedure. Cleanup design, cleanup routing. We looked at this earlier. Alright, we're going to cut the tape here, post-processing layer details.